Now in this session we will talk a little bit more about Sipser's tricks for dealing with the problem, what happens when you have a first square on your tape, which personally, in fact it's probably a good moment for me to digress a bit on that particular question, because I'm becoming increasingly frustrated by it. I see it as totally unnecessary. I suspect that Sipser has got himself into what the French call an idée fixe, in other words, like a fixed idea. Because so much of these problems that are arising, that we'll talk about for what they're worth, that arise from having a first square, so the first square on the left-hand side of the tape, and then the tape extends infinitely to the right, your right. And the alternative is simply just to have the tape be extendable infinitely both ways, left and right. And then you just insert your string, your initial string of symbols, just anywhere in the string, but position the head over the leftmost symbol of the string. Okay? And then you automatically know when you've reached the edge, either the left edge or the right edge of the string, by the fact that you hit a blank. Okay? It seems to me sort of obvious. Now, as I was writing the board, I came across the possibility that your string might just be a blank. That's it. It's just the empty string. The string might be empty. And that stopped me in my tracks for a moment. But then I thought, well, you could have the header still over a blank and still have, you could avoid the problem of having a leftmost square. So it seems to me, that's not an objection. So to persuade you, or to attempt to persuade you of the superiority of that idea, so that it's not just my idea, I thought it might be, so I put myself in the position of a lawyer, let's say, and I'm now making out a case that I think it's a silly idea, that it's better to have the tape infinite both ways, and then you can avoid all these problems that he's having, and so I found another authority who is of comparable status with Sipser. In other words, another MIT professor, famous, probably more famous than Sipser, and that's Marvin Minsky. Now, Minsky is one of the founders of artificial intelligence, AI. Because that's sort of my area, I knew him well. We met many times at conferences and so forth. And at one stage he got very enthusiastic about the work I was doing with artificial brains, because he thought for a while, and then he changed his mind as always, he thought that perhaps his vision of looking on the human brain as a society of, what do you call them? Agents, where each little agent did its own little job. And my artificial brain design was, I would evolve, in the latest electronics, I would evolve neural net modules. I call them modules, but you could call them agents. And each of these little neural net circuits or modules would do its own job. So there's an easy correspondence you can make between a Minsky-like agent, so little bits of software, if you like, and my neural net modules. And Minsky could see that immediately, so he got very enthusiastic for a while. Anyway, that's a side issue. Now Minsky, early in his career, he wrote quite a famous little book, very similar to all this, on the theory of computation. And it's called Computation, Finite and Infinite Machines. Now here's the book. Okay. Now I will teach it at some stage. It's about, I guess also at M1 level, I suppose. It looks about M1 level. But it goes into quite other things than Sipser does. But anyway, the point is, the reason why I'm talking about Minsky and his book is, and that Minsky's at least as a renowned authority as Sipser, or probably greater, is on page 118 of Minsky's book, which is the second page of the chapter, which is chapter 6 on Turing machines. Towards the bottom of the page, he talks about the tape of his of Minsky's Turing machine, and I'll quote: "The tape is regarded as infinite in both directions." Okay, I rest my case. So I feel a bit more self-assured that when I'm disagreeing with somebody of Sipser's status, if somebody like Minsky agrees with me, then I hope you'll agree as well. Anyway, for what it's worth, if you do have a first square on the left, so there's a boundary there, how do you cope with the problem when you're, say, scanning left? How do you know when you've hit the last square? Well, one of his ideas, we're talking about one idea, so now we're talking about his second idea, and it seems rather clumsy, and it seems to me also avoidable. Anyway, here's what you do. You, on each square, as you move, you write a special symbol, right, on every square as you move left, assuming that there is a boundary on the left somewhere. So at each square you write a special symbol, and you record in your control the symbol that was there. Okay. Now, say you are positioned at the leftmost symbol, and you try to move left again, but you can't. So you stay in the same symbol. You stay in the same square. You don't move. And then you read the symbol that's there, and if it's that special symbol, then you know you have not moved, and therefore you know you are at the leftmost square. Right? You're at the edge. You're at the left edge. Now, as you're moving to the left, as you move, you've got to restore the symbol that you overwrote with the symbol that you stored earlier. So you don't want all the left symbols overwritten. So you write unwrite at each square, and this is a technique that allows you to detect when you're at the edge. Now, what a pain! It seems. Another criticism of Sipser, but let's keep things balanced. I'm impressed by his general structure. I can see why he's chosen each topic and in the order it's done. In his presentation of the examples, often he'll use an earlier one to help him solve a later one, and so on. It's very well structured. No one's perfect. I can't. I have a bit of a criticism with his lack of clarity at times. He could be clearer, I feel. He could also, I think, have pitched the intelligence level of his presentation closer to the average level of the students who would read his book. I still think there's a bit of an unconscious bias creeping into his writing, where he assumes some statements are very obvious, maybe to him and the students he's accustomed to, because they were MIT students. But